Hi guys, welcome to this first in a series of a few videos where we're going to have a look at some methods of factorization. Now factorization is one of those sort of essential algebraic techniques that you've been exposed to, if that's the right word, over a number of years, to ways of factorize different algebraic expressions. And what we're going to do here is go through some examples of some of those essential techniques. And the first of these we're going to have a look at is factorization, where we're going to be trying to factorize by taking out common factors. I think the best way to have a look at this is to actually go through just a few examples. So here is an example. We're asked to factorize 6x y squared minus 18x squared y. Now, whenever you factorize, and let's just pause for a moment to say, well, what do we mean by that word, factorize? Well, let's take a numeric example. If I take the number 24, now I can write 24 in many different ways, but one way of rewriting 24 would be to look at its factors. So I could say, well, that's 12 times 2, giving 24. So one way in which we could rewrite 24 as a product of its factors would be to say it's equal to 12 times 2. Now, of course, you could also say it's equal to 6 times 4 or 8 times 3. And these are all different ways of writing it as a product of its factors. And of course, 1 is always a factor of any number, so 1 times 24 as well. Now, I think that's all the different ways I could rewrite 24 as a product of its factors. So the key words here are product of factors. Now, one word here, maybe I'm assuming you understand what factor means. Well, factor has quite a definite, precise meaning. If you look at 24 again and you take any of these numbers, 1, 3, 8, 4, 6, 2 and 12, all of those numbers go into 24 evenly with no remainder. So let me take one example. If I divide 24 by 8, well, it goes in 3 times exactly, and the remainder is 0. And if the remainder is 0, it means that 8 is a factor. It went into 24 evenly with no remainder. So, recapping some key essential ideas, factorization means to write as a product of factors. And what is a factor? Something that goes into something else with no remainder. Now we need to look at how to apply that in an algebraic way. So let me just remove some of this stuff here, and we'll have a look at that example on the left there. So to factorize this, one of the key essential methods is always to look at common factors. So what does that mean here? Well, we have a look at both of these parts of this expression here, and we're going to take each of the numbers and each of the variables in turn of each part of this expression. So let's look at the 6 and the 18. Well, I can recognize that 6 is a factor of both 6 and 18. So in fact, it's the highest common factor of each of those two numbers. So that is a factor I can take out from each of those two numbers there. If I look at x and x squared, well, x is a common factor of both of those. X can be written as x times 1. X squared can be written as x times x. X is a common factor of both of those. And notice that we're taking out the highest power, which is common to both, or to put it in another way, the lowest power of x and x squared, which is common, is x. Okay, and let's have a look at y squared and y. Well, following a similar argument to this here, I can see that y is the highest common factor of those two parts. So I can take that out as a common factor as well. Now, having done that, we then put a bracket and say, right, I need to get this original expression back. What would I multiply 6xy by to get 6xy squared? Well, I need to multiply that by y, so that would go there. So that times y would equal this part here. Okay, 6xy times what to give negative 18x squared y? Well, I need a negative 3 to give the negative 18 back, and I need to multiply x with another x to give the x squared back. And I've already got y here, so multiplying 6xy with negative 3x, yes, that will give negative 18x squared y. So let's close off the bracket, and that is now factorized. Notice that we had to take out all the common factors. I couldn't, for example, say, let me just put this over here and say, oh, well, let's just take out x6 and let's just take out the x. Okay, and then we'll just put y squared minus 3, what else have we got here? 3xy. That is an incomplete answer because y is still a common factor of y squared, and y should have been taken out the front. So you must take out all the common factors. Okay, let's take a look at another example. Okay, let's take a look at one that might involve some fractional terms. So let me just put that example here. Okay, and let's say we had this a over xy plus b over x squared y squared. Okay, so once again we can look at these two parts here and say, well, does a over xy and b over x squared y squared have any common factors? Well, yes. There are no common factors of a and b. Now I am assuming that we are familiar with this idea that when you multiply fractions together, you multiply across the top and bottom to get the result. So what I'm trying to do is to take out some factors out the front that when I multiply it with the things that are going to be inside the bracket will give each of these back. Now a and b don't have any common factor in terms of algebraic variables. So I'm not going to take out a or b. So what do I take out the front? Because I need to have a fraction. Well, I can take out 1. 1's a factor of anything. Okay, what about x, y, and x squared, y squared? Well, following a similar argument to these things over here, I think that x and y, x is a common factor of x and x squared, y is a common factor of y and y squared, so I can take xy out the front. Okay, so if I do that, what would go inside the bracket? Well, 1 over xy, what do I multiply that with to give this back? A over 1, and yes, that could just be a, plus, well, I need b on the top of this fraction here to give that b back, and I need to have xy on the bottom, because if I multiply xy with xy, it gives me back that x squared y squared. And yes, that could also be written like this. Okay, and let's move on to a further example. Okay, sometimes we might have fractional powers. So what about factorising x to the power of a half minus x to the power of, let's say, 5 over 2. Okay, so what do we do here? Well, as I mentioned up here, when we're looking at these common factors, we're basically taking out the lowest power, okay, of these two. Okay, well, the highest, well, yeah, how do you, we could say that it's x and x squared the lowest power which is common is x, or is it the highest power which is common? Okay, the basic idea is it's the highest power which is common to both, okay, would be x in this case. So if I look at x to the power of a half and x to the power of 5 over 2, well, the highest power which is common to both of those, okay, is x to the power of a half. Okay, so that's what I'm going to take out the front. Okay, so x to the power of a half times what to give this back? Well, 1. Okay, I must have to have a 1 there, otherwise I haven't got anything to multiply it with to give this part back. Now what do I put here? Well, the question is, I've got x to the power of a half out the front. I need to multiply that with some power of x to give x to the power of 5 over 2. Well, if you think about your laws of indices, whatever you got here, you'd multiply with a half to give this result. Well, if you think about a half times 5, that's 5 halves, or 5 over 2. So it must be x to the power of 5. Okay, and that is the correct answer. And that was example 3. And let's do one last example, and we'll fit that over here. Example 4. What do we do when we've got some fractional, negative powers? So what about if we had p to the power of -1 plus 5p to the power of -3? Okay, what do we do in that situation? Do I take p to the power of -1 out as a common factor, or p to the power of -3, or something else? Well, the convention is we're going to take out the lowest power. Okay, so p to the power of -3. Once again, the lowest power which was common to both of these was x. So we're going to take out the lowest power which is common to both, and that is p to the power of -3. So when you've got negative, look for the most negative as your common factor. Okay, so what's going to go in here? Well, p to the power of -3 times some power of p has to be p to the power of -1. That has to be p squared. And we need that 5 here. It's a plus, so 5. And that's it. So 5 times p to the power of -3 would give this back. So there's our solution there. Alright folks, that's some examples of common factors, and the next video we'll have a look at factorising by grouping.